Welcome. This is our webinar in partnership with Hexagon and Immersal. The title is Architecting Practical AR Solutions in Industrial Spaces. And let me start sharing my screen here so you guys can see it. Okay. I believe you all can see my screen.
Yep.
Okay. Thank you. Well, I am May. I am the head of developers community here at Immersal, and today I'm together with Frank. So please, Frank, you can introduce yourself.
Hey, hello everyone, whether you're watching live or the recorded video, thanks for taking the time to join us. I'm Frank Suykens, Senior Vice President of Visual Computing at Hexagon, and yeah, working a lot on R&D and development on computer vision, visualization, AI, augmented reality, virtual reality, and yeah, happy we can talk today about some of that to you.
Okay.
And maybe, yeah, to give you a brief overview of what we will cover today, I will give you a very short introduction on Hexagon, a company that is heavily involved in digital twins. And what we see is that the rise in digital twins drives the need to capture industrial spaces, so do reality capture of those spaces, making those spaces digital. And those digital twins have many use cases, as I'm sure you know, but we also see this becoming a big driver for AR, augmented reality experiences. And the key to building AR experiences for industrial use cases, in our view, are three things: capturing the physical, the real space, reality capture, visual positioning, which kind of answers the question of, okay, this is what I see, this is what my camera sees, where am I giving the 6 degrees of freedom, location, and direction. So visual positioning is a second part. And then, of course, third part is building the applications. In this webinar, we will mainly focus on the capturing of industrial spaces, visual positioning, but of course, show you some use cases of augmented reality applications and use cases that we have done. But May will focus especially on the visual positioning. That's the biggest part of the webinar today, but also talk a little bit about use cases with visual positioning beyond augmented reality. And we leave some time for Q&A at the end, so leaving some time for questions. But first, please allow me to show you a 1-minute video that captures the essence of Hexagon's work that you see here. Hexagon is a big company, active in a lot of different industries, different technologies, sensors, software, platforms, and doing things like AI and empowering different industries that you can see here, mobilities, smart cities, and we try to have really an impact on those industries. So touching a lot of smartphones and airplanes and buildings and tunnels across the world. 24,000 employees, so fairly large, global, and spending a lot of time on R&D to make the best technology to allow you to build super applications. So a short intro on Hexagon, and if you can go to the next slide. As I said, yeah, we try to make an impact on the world with our technology, with our sensors, with our software, and with our platforms. You see a quick overview here of some of the things that are being touched by the Hexagon technology. And if you go to the next slide, you can see some of the industries that we are active in: construction, transportation, smart cities that I mentioned, media and entertainment, where you see a lot of augmented reality, but then also, yeah, industrial industries where we also see a rise of augmented reality, and we'll show some examples of oil and gas and mining, for instance, but also some examples in other industries. So let's dive into the topic. And as I said, Hexagon is quite active on digital twins. And in fact, we, as Hexagon, we just released a digital twin report. You can see the URL on the slide here. I really recommend you to check it out. It has a ton of super interesting statistics. We surveyed over 600 people in different industries on their use of digital twins. And one of the outcomes of the report is shown here, the percentage. It's actually a quite high percentage of users of digital twins that in the survey mentioned to us, like, okay, by using digital twins, we see a significant increase in collaboration as one of the benefits of those digital twins. And this is caused, in our view, because users can, with a digital twin, interact with the digital space, with the digital replica of the real world, do that easily, and that enables collaboration. But what we also see and think is that augmented reality is a great way to enhance even the use of the digital twins, because augmented reality really can bridge that gap between the digital twin and your real physical space, allowing you to be in the physical space, but at the same time use the data of your digital twins. And the digital twin industry is expected to grow by a factor 10 in less than 10 years from now. And this is according to Forrester. And that's a huge growth that we're expecting for digital twins. Now, why is that important for us today while we're talking about augmented reality? Well, as I said, typically augmented reality and extended reality, AR, XR, require a digital twin of the physical space that you're enhancing with AR. So you need a digital twin to do AR, but at the same time, AR and XR can enhance the use of the digital twin, because you can, as I said, bridge that gap to the physical space and do to bridge really the interaction gap between physical and digital world. And that is why we at Hexagon expect a significant increase in AR, XR applications, really riding the wave of digital twins in the next years. And here's an example of a use case of digital twins and augmented reality that I really like. So this is a simulation of airflow in a clean room. And this is useful for designing and analyzing the air conditioning, purification of air in a clean room environment. The simulation, CFD simulation, is done by our Cradle simulation software. And this AR application is done by our May Hertonen team based in Oslo. And it's really cool how it shows that airflow inside of the room. And you can imagine that in a clean room, to really understand airflow and what comes from the vents and how the air flows over tables and floor, that doing this using an augmented reality application like this adds tremendous value. What you also see is, if you look closely here, the use of markers. So you see some markers on the walls, for instance, which allows you to align the digital twin, the digital space, with the real space. And it works. And I specifically picked this video as well to show you that, oh, can you go back? To show those markers, because it works, but it's not necessarily practical to do, especially for large industrial spaces. And that is why today we typically use Immersal and visual positioning system of Immersal to solve this localization problem elegantly without having to use markers in the room. Then the next slide shows you another example. So this is a digital, let's say this is an industrial space that we all walk over daily, the pavement, but especially below the pavement where you have the underground infrastructure, you could see as a real industrial space. And also here, as you see in this application, also done by our MyVR team, allows you to see through the pavement and show that infrastructure. So this is again a very nice example of augmented reality in an industrial application. And again, of course, you need visual positioning to see where you are, relate the digital and the physical world. Your underground infrastructure can be purely digital, like pipes in a CAD, as you see here. But if you really want to know that your CAD drawings of pipes correspond to what's really under the pavement, you could also use ground penetrating radar. If you can click and show the images, May. Yes, here you see one of our ground penetrating radars with then on the top a view of a similar augmented reality view, but showing the response processed through AI of the ground penetrating radar, and that gives you that certainty where infrastructure is below the floor. So how to go about building such an AR experience? What we see is that many companies and many of our customers see the benefit, they want it. But what we also see is that at today, maybe fewer than we would expect of our customers are actually using augmented reality. And we think that making the capturing of spaces more practical and doing more practical visual positioning can really help change this and increase the use of augmented reality. And building an AR requires three things, as I mentioned: reality capture, visual positioning, and building the application. And let's look at capturing industrial spaces. You can do it with images, taking a lot of pictures, but at Hexagon, one thing that we believe is that using a combination of LiDAR and images has a lot of benefits. And you just saw someone walking around with a BLK2GO. These are all LiDAR and image sensors from our BLK line. A BLK2GO is super easy to use and is a great device to both capture the digital twin, but at the same time use that input for generating a localization map for visual positioning. And here, what you see here is our BLK ARC device mounted on a Boston Dynamics robot, which, just a second, which in fact also uses Immersal technology to do localization, to do advanced path planning for the robot. So this is, I think, also a use case that May will talk about. So using LiDAR devices captures a ton of data, both point clouds and images. And then the next step in capturing physical spaces is to manage that data. And if you go to the next slide, this shows you the capture or a scan of with one of our devices of obviously a very industrial space. And this is here shown in Reality Cloud Studio. It's our cloud platform to make it easy to manage scan data, share scan data. It's cloud-based, so you can very easily share it. What you see here is a mesh that's automatically generated from the LiDAR and the images. So it really makes it easy to work with the gigabytes of data that are generated, especially if you capture super large spaces. And one practical advice maybe that we have on building AR is when you're capturing data from the physical world, from the real space, is make sure you capture it in a way that you can use it both for creation of a digital twin, like you see here, and for the creation of the necessary data you need for visual positioning. And as I mentioned, BLK2Go for us is a really recommended way to capture some of these spaces and use it with Immersal at the same time. Really, really easy workflow. And also here, most of the industrial facilities and cities and pavements across the world have already been built. So many of our customers just don't need an AR application. They really need that digital twin to be created. And this can come all together. Here's an example of something that was built long ago, the Qutub tombs in Hyderabad in India. And we captured this space with a ton of different devices, making it really a showcase of an archaeological site. You saw the textured mesh created, but you can do AI and classification and use the point clouds and all the different information just by capturing the space in one go. With LiDAR, you also get geometrical accuracy where you can do accurate measurements, which is also essential if you're in industrial applications. It's not just placing a cool dolphin in an amusement park. This really requires super accuracy for industrial applications. And if you go to the next slide, this brings us, I think, to the second point where we say, make sure you capture the space correctly for digital twins and for AR applications. And then an important second step is visual positioning, where I leave it to May to give you more details on that.
Okay, thank you very much, Frank. So talking about visual positioning, then we need to talk about Immersal. So for you who are not familiar with Immersal, Immersal is a Finnish company. We were founded in 2015 and acquired by Hexagon in 2021. And we offer the most versatile visual positioning system in the world. Why I say the most versatile? It's because, as Frank mentioned before, we are doing lots of projects and including in mining. So I will show you later a video about how Immersal VPS works even in mining in underground conditions. So this here, what you can see is a video where we were just testing our localization. So basically what it means is you need to create a spatial map of the place. And then after that, you can test the localization. You can do the test, even if you do the map with the BLK2Go, which is a device that we would recommend you to use in most of the cases, or the BLK Arc, depending on how big the space is. Once you have done the map, you can test the localizations to see how successful that is. You can do that if you are on site, you can do that using the Immersal mapper. So you just download the map that you have already created on the Immersal mapper phone, and then you can just test the localization, basically clicking on AR and testing the localization. It's quite easy. But if you don't have the opportunity to be on site to do that test personally, so let's say you work in a remote team and then you are working in a country, but the application is actually being built for another team in another country, so you wouldn't have access to that specific environment. This is where our remote testing will play a big part, and we will show you later in real time how you can do that, how you can test some localizations using some images from the Immersal mapper. So here, all those blue dots that you can see, those are feature points. So basically, you can see that they kind of get together when you have some unique images, some unique features. That's what we mean by localizing. So we are able to match exactly what has been mapped before with the image that we are seeing right now. Then why would you use that? So here is an example of creating an AR navigation in an oil rig. So let's say, for example, you need to do some maintenance, and we know that the team is not really familiar with the place. Sometimes they are outsourced, so they are not familiar on how the site works, on the layout and everything. So then you can easily create a navigation that would guide the team, the maintenance team, to go exactly where they need to go. So I will show you later another example as well. But this is just to give you an idea of how it would look like. You did see probably some of other kind of destination points visible there, but that's only because this was a quick demo that we created in just a couple of hours after doing the map, because it's quite easy to do that. You can, of course, disable that and make them and hide them during the navigation. So you can only have the one that you have selected visible, but this is just a demo. Okay, so let's talk a little bit about the workflow to use Immersal. I mentioned about doing the spatial map. So what you can do to do the spatial map, you can use your phone if it's a small location. If you're just doing a test to try out the technology, you can just use your phone to map your office, for example. And then once you have done that map, what we will do is we will create that map. Basically, what you need to do is take some pictures or a video recording, because the information that we need from the device is only the images with the camera pose. So the images could be from a phone, could be from a LiDAR device, could be from a 360 camera. Once you have captured that, we will use our Immersal REST API that's already embedded into the Immersal mapper if you're using the phone to do the mapping, or if you're using a BLK to go, you can just go to the developer portal and just upload the file from your account. And then we will use that information to generate the map and store that in our map database. Then comes the second part about the localization. So what you need to localize is basically any device with a camera. So you can use a phone, you can use AR glasses, you can use a camera from a robot, you can use a camera from an equipment, even a body cam. We have also done some tests even using a Raspberry Pi with a camera. So even that small camera with not that good quality is still able to localize. The key is to get a good map. And to get a good map, we recommend using the Leica devices. So again, for localizing, the only thing that we need is the image and the camera pose. So once we have that information, we run that through our REST API in our service, and then we do some kind of matchmaking with the images that you have collected from the map when you were doing the map and when you were localizing. So when we mean localizing, it's basically taking your phone and looking around. And while you are doing that, the phone is actually taking some pictures and sending that, and we are comparing that to what we have in the database. So we leverage here both a little bit of AI, machine learning, and spatial computing to be able to find that exact match. So once we find that exact match, we reply back with response with the location and the orientation of the device. So you can see exactly not just where you are, but where you were looking at. So you can see both the location, exactly pinpoint, and also the orientation. I will show you a video soon so you can have a better understanding of that. One important thing about Immersal is the data ownership. So with Immersal, when you created a map, you own the map. So you decide where to share, how to share, and who can use it. We do on-premise and on-cloud. We do on-premise and on-device as well. So you can localize only using the device if you're in a place where you don't have that good internet connection, or if you would like the data to be kept in your servers, you can also do that, and you can use our on-premise deployment basically. Then you may think about scalability. So how big is the space that you can scan? So no space is too big. We have mapped warehouse, theme parks, museums, stadiums, and you can map even the whole city. Here is a real map of Helsinki. You can see that started from a statue that we have in Helsinki up to a couple of city blocks. This is a real map that we have done of Helsinki, and it can be much bigger. Well, that brings us to what Frank mentioned before about the digital twins. once you have the digital twins, augmented reality is the best way to visualize it. And you can use that in partnership with some other technologies, for example, and then you can not just visualize the digital assets, but you can also have some integration to have some real-time information. And then you have all of that using that physical location as an anchor. So you'll make sure that that information will be displayed exactly for that exact machine or that equipment or something. So this is the key about using VPS. This here is a real example of AR that's a use case from one of our partners. It was implemented by Fly AR, and this was for Caverion. So here you can see some bin data overlay, and that can be used for the maintenance team, for example. You can also see some IoT information for some equipment. So you can have some information to train a new person that just joined the team. Or if needed, we mentioned that sometimes the maintenance team will be from an outsourced company. So you can navigate them to get to the exact place. And you can see how many things that you can do with this. So you can have bin overlay, you can also have some other information. Everything that you can scan, you can augment it, basically. So it's up to you how much information that you would like to see. You can also toggle between them. So you could hide it, you could show it, and then you have some layers. And it's everything so easy to build. Then some other use case in the industrial space. So imagine now that you are an employee and then you are working in a factory, and then you can see that there is an equipment that needs maintenance. So what you can do, you can basically take your phone, take a picture, report that maintenance is needed. Here, the developer can also build some other integrations to allow the user to add some text or voice to text, adding more information about what's needed, if they have any idea what happened or what they would need to be fixed. So they could add that as an extra opportunity for the maintenance team. And then what VPS will do, VPS will make sure that that picture will be pinpointed to that exact location, which will facilitate when the maintenance team will be able to go there later to fix it. And again, you can work together with AI, for example, so you can not just use that image for VPS, you can also use that in partnership with AI to understand what tools the maintenance team will need to work and to solve this issue. So that's also how you can work together with some other technologies. This here is a very quick video showing the workflow using Immersal with BLK. In this case, it's a BLK Arc and BLK to go. So here you can see the BLK Arc, which is the Boston Dynamics robot using a Leica device, a BLK device on top of it, and it will do autonomous mapping of the place. It can also be combined with mapping from the BLK to go. So you can do the mapping from different perspectives. And while you can have the robot doing some kind of mapping, you can have another person doing the mapping of another part of the environment, for example. And then you can have those different angles as well. Then the scan data is used for the visual positioning. So we provide hyper-accurate positioning and orientation from the camera image, and this enables you to create augmented reality experience. Here you can see an example of the digital twin of the scan data that's created into this spatial map for Immersal. This is the example that I mentioned about pinpointing the exact picture to the exact location that will help the maintenance team. So now once you have that information, you can easily create an AR or even a 2D wayfinding for the maintenance team to get to that place. And as Frank mentioned before, BLK Arc also uses Immersal technology VPS to be able to navigate itself to perform some autonomous task, being able to understand where it is in the space and where it needs to go. Well, Frank also mentioned that VPS can be used beyond AR, and here is an example for mining. So this is one of the mines where we have run a couple of tests. So we were able to map that and create, you can see this is the tunnels of the mining. They are not the same shape, they are quite tricky, but we have improved our technology to be able to localize even in this kind of a challenging environment. So we provide precise real-time information. So then you can use that to create, for example, asset tracking. This here is an image from an asset tracking that we did in a train station here in Helsinki. And in this case, there are 3 different devices because we work across device compatibility. So you can use iPhone, iOS, AR glasses all at the same time, and all of them will have the same information. And this is an asset tracking in the mining. So you can see where the truck is or where someone is, and then it helps you to reduce downtime. So this is just an example on how VPS can be used beyond AR in mining. Well, okay, enough talking. So let's do something easy, something simple like remote testing I mentioned before. So we have a REST API that allows you to do lots of things, including creating support for on-cloud localization for AR glasses, as long as you have access to the camera, because you will need that information to be able to localize the device. So let me just stop sharing this screen here a little bit. And then I will show you something. So let me just go here. I will just show you how you can get into the Immersal developer portal. So you have 2 ways. You can just go to the immersal.com website and go to developer portal, international server here, or you can just go to developers.immersal.com. In this case, I was already logged in. Then you can see my ID here. This is my developer ID, and this is my email. Just to clarify the name, it's just that I got divorced and I changed it. So I'm still in the process of changing everything, but still is me. Then you can see all your maps. You can see your account here. This is where you can find your token. Then you have the support, and the easiest way is to go to our documentation. What we will cover today is under maps and mapping, and then you have this map advanced and then map testing. This is what we will do here. So what I did before this webinar, I did a map of just a sofa, a couch that I have here in my place. It's just a gray sofa. And then what I did, I took after some images, just testing images under different lighting conditions. I changed a little bit the environment just to make sure if it would still work. And sometimes it should work and sometimes it should fail on purpose. And then here is how you can, after you have taken the images, instead of creating the full map, so you'll just give the name of the map, and then you don't need to upload the images to the cloud to process and generate the map. You can basically click on this button here that will allow you to share the images. So this is why you can do this in partnership with someone from a different team, from a different country, for example. So the key here is to share the testing images from the Mapper app. You can do that using AirDrop, email, or everything. I personally like AirDrop because it's the easiest way to get the information. So you will get a zip file, and once you get to that, you need to extract it, and then you will have a folder with the images. Not just the images, but the JSON file with the metadata information that we will need to do the localization. So in this case here, I will just go where I have mine. I can actually delete the previous one here, so we can do it together. So this is the images that I have, and this is the script. That script can be found on the same page, and then you can just click here. So this is just a Python script. We do require a couple of tools to be able to run this. So I went ahead and I've installed this. I use Conda to manage my Python environment. So what I will do, I will just use the terminal from my Mac to be able to activate and to run my scripts in my Python environment. So let me just activate this. My environment, it's called IAM Tools. And here, what I will do, I will find the place where I have my Python script. So I can just copy it from here. Then once I'm inside of this, I will run my Python script. So this is the Python script. I will just copy the name here, .py. And what this will do, it will run the localization against those images to be able to tell me if it localizes or not. So it will take a few seconds or a few minutes, depending on how many images you have. Then you can see this true or false, just meaning that you were localizing to the environment, yes or no. And then at the end of this script specifically, you get these images here where you can see the localization. You can see also the point clouds here to be able to identify the unique pictures. So you can see under a different lighting condition, I also added a backpack here. I changed the chair here to a different position as well. You can see the lighting here. You can see a different lighting condition. The blinds on, the blinds open, the blinds closed. So then you can see how successful it was. And at the end, once you have finished running that localization, you can still see here of the images that I have taken, the ones that were successfully localized, you can see where I was looking at. So you have all the access here from the camera, where you can see the position that I was looking at and what I was able to capture there. And then here you can see how many images I took in total, 13, and then 10 of them were successfully localized, and then 3 of them failed. Then you can see the percentage here. This is how you can see if this was a good map to be used or not. Okay, I will close this. And now I will just stop sharing my screen here. Okay. So I believe now we have time for questions. Let me go back to the presentation here. Let me share my entire screen again. Okay. This is just the images that I mentioned. Then here, also, sorry, I forgot to mention about the benefits of using Immersal VPS compared to ARKit and ARCore, as many of you could have this question, because this is something that you can just think about, okay, but I have ARKit and ARCore. Why should I just use Immersal instead of using that? So basically here are some of the key differences between the technologies. So Immersal VPS is more for large and complex spaces. So if you have just a small space that you just would need to create a small experience, yes, you should still be okay using ARKit and ARCore. But if you would like to have a persistent experience across device, so Android, iOS, and AR glasses, then you would need to use Immersal VPS. Otherwise, you wouldn't be able to use ARKit and ARCore to create navigations, for example, and multi-user experience. Some of the key takeaways from this webinar that we would like to share with you is that it's quite easy to create a first prototype. So you just need 1 or 2 people team and just a few weeks to create the first prototype. We recommend Leica devices for mapping, specifically Leica BLK2Go and BLK Arc. BLK2Fly would also be okay, but you just need to remember that you need to scan from the perspective of the user. So if it will be used by a robot, we recommend scanning from that angle. If it will be used by a human, so we recommend using BLK2Go or even BLK Arc with a different angle. And then BLK2Fly would be if you would be using the VPS with drones. Then a reminder that VPS goes beyond augmented reality, and it can also be used for asset tracking, for example. and there is no need to be on site to test the localization. And you can easily sign up for an Immersal free account using this QR code that you can see on the screen, or just to go into our website and sign up from there. Yes, now we have time for questions.
Hey, May, there's one question in the chat from David. How does the localization and registration work in rapidly changing manufacturing spaces?
Okay, so that's a great question, David. So basically what happens is I showed you a couple of pictures where I changed a little bit of the environment. So once you are able to localize up to 50% of the same conditions of the environment, you are still able to use Immersal VPS. You need to have some consistency. So it can change, but it cannot change more than 50%. Otherwise, the localization will fail because we need to have that exact same kind of unique features to be able to localize and use the Immersal VPS.
Okay, and then a question from Sahil on slides and video of the webinar being available.
Yes, it will be available. This is a LinkedIn Live, so it will be recorded. It will be available on LinkedIn. We will also make it available on YouTube, and we will also share a link for the slides presentation. Okay. Do we have more questions?
I don't see new questions in the chat. Feel free to post.
Yes, I don't see more questions. So also just to let you know, feel free to connect with me on LinkedIn and drop me a message or send me an email at may.hertonen@immersal.com. So feel free to connect with me and send any questions that you may have. And you can also feel free to let me know if you would like to have a one-on-one call where I can go into more details about mapping techniques and what else you can do with testing, REST API, and everything else. How you can use Immersal VPS to enhance your augmented reality location-based experience.
And same for me, please feel free to connect with me on LinkedIn. Happy to be in touch. And then I guess thank you again for your attention and watching the webinar. And from my side, really recommend trying out Immersal, because also from my teams, we really love that technology.
Okay, Frank, I actually just saw there is another question here from Shumik Islam. I'm sorry if I mispronounced your name. I am interested to learn how do you create mapping in hazardous sites and where micro-robot accessibility might be required for mapping. So that's an amazing question. So you always need to keep in mind about the person that will be doing the scan to make sure that they have enough safety equipment, or depending on the environment, if you can't have a person to do the mapping, that's where we would recommend you using the BLK ARC, for example, because then the robot would be able to do the mapping in those environments without any risk.
Yes, indeed. And the BLK ARC, you saw it on the Boston Dynamics, but it's really a platform that can be mounted on other types of robots as well. So also on smaller robots could be mounted and used in, let's say, tighter spaces.
Okay, so thank you very much, Frank, and thank you everyone who attended the webinar and who are also watching it later, just the recording. Well, have a lovely day or evening.
Thank you, May. Thank you, everyone. Goodbye.